Okay, so we're going to continue with some of these other questions. We're going to skip questions 17, 18, 20, so it's 17, 18, 20, and 21, I think. And the reason why is because to do those questions, we need to do something that we call differentiation. Okay, but differentiation is something that we're going to be doing later. Okay, probably next term. So we're going to leave those questions for later. So and then yeah, we'll come back and then do them. But for now, we're going to continue with question 19. Okay, question 19. Question 19 part I, they say that you have to state the remainder theorem. Okay. All right. Okay, to state the remainder theorem. The remainder theorem says that if P of x is divided by x minus a, comma, P of a is the remainder. That's all what it says. Okay, and yeah, you gotta remember that. You got to remember that this will help you to find the remainder when you don't want to do long division or when you don't need to do long division. Okay? All right. Okay, so that is part I. So that was sort of easy. And the next part, I'm going to test my pen. Yeah, this one is good. Okay, the next part say this. They say if px is divided by ax, so if the divisor is ax, giving a remainder of rx, what can be said about the degree of rx? Okay, so we know that when you divide by a divisor, the degree of the remainder have to be 1 degree lower. Okay, so that means that we're gonna say that the degree of the remainder have to be smaller than the degree of the divisor. Okay, so the degree of the remainder is always lower than the degree of the divisor. And this is something that we're going to be using for the next part of this question. Okay, so the next part of the question say this. If a certain polynomial p of x is divided by x plus 1 and x minus 3, then the respective remainders are 6 and negative 2. Okay, so we're going to write it down straight away because that's something that we're going to be using. Okay, so if we divide by x plus 1, the remainder is 6, so p of negative 1 is equal to 6. And when you divide by x minus 3, so p of 3, the remainder is equal to negative 2. Okay, so this is something that we need to have in mind. But then they said that we're going to find the remainder when this polynomial is divided by x squared minus 2x minus 3. All right. Okay, so we need to find the remainder when that polynomial is divided by x squared minus 2x minus 3. Okay, so these are the questions. So find the remainder when p of x, okay, when p of x is divided by x squared minus 2x minus 3. Okay, so I'm going to do the solution here so I have more room. We're going to say this. Okay, so this is solution for the second part of this question 19. All right, here we go. Alright, so we're going to say p of x divided by x squared minus 2x minus 3 is going to be equal to some quotient plus a remainder. Okay, so it's going to be equal to that plus a remainder. Okay, now it's when we are going to use this. Okay, how? Like this. If we are dividing by a quadratic or a polynomial of second degree, we know, okay, we know that the answer for the remainder have to be of lower degree. So that means that this is going to be a linear polynomial. So in other words, we say this. We're going to say given that the degree of x squared minus 2x minus 3 is equal to 2, then the degree of the remainder have to be equal to 1. And when you have a polynomial of degree 1, so then we can say then the remainder is going to be a linear, so it's going to be something that looks like that. Okay, so that is what we are going to have. All right, okay, and then let's see how we're going to do this. Okay, so then, so when I say, I'm going to call this 1. So from 1, we have p of x is equal to x squared minus 2x. So we're going to express this in the other form, that we know, and it's going to be equal to x squared minus 2x minus 3 multiplied by that polynomial or by that quotient that we don't know, and then plus ax plus b. Okay, all this can be done as, okay, this can be factored as x minus 3 and x plus 1, and then all multiplied by this, and then plus this remainder. Okay, so with all the information that we have, we can go from here to here. Okay, but then in addition to that information, we know that p of negative 1 is equal to 6 and p of 3 is equal to negative 2. So we're going to substitute those numbers and equate them each time to 6 and then to negative 2. Now, if you can see that p of negative 1 will make that equal to 0, so that means that all this will be equal to 0 up to here. Okay, and then what is left is ax plus b. So we're going to say ax plus b, and also, sorry, we need to substitute the negative 1 in here, so it's going to be a times negative 1, so it's going to be minus a plus b, and all that, they say that is equal to 6. Okay, so p at negative 1 is equal to 6. Similarly, if we substitute 3, the answer is negative 2. Okay, so p3, which is equal to the same thing. If we substitute 3 in here, so it's going to be 3 minus 3, so all these will go, and what is left is only that bit in here. Okay, we're going to substitute 3, so it's going to be 3a plus b, 3a plus b, and that is equal to negative 2. All right, so we got that. And that will give us, those two equations. That will solve them simultaneously. So then we have negative a plus b is equal to 6, and then we have 3a plus b is equal to negative 2. 1, 2. And then we're going to take away. Okay, so we're going to do equation 2 minus equation 2, equation 1. Okay, so if you do equation 2 minus equation 1, then you're going to have 3a minus minus a, so it's going to be 4a, b minus b, they're gone. It's equal to minus 2 minus 6, so it's going to be minus 8. So therefore, a is equal to negative 2. All right. So we have that. And then to find b, well, we substitute b in here. So we're going to say from 1, we have that b is equal to 6 plus a. So therefore, b is going to be equal to 6 minus 2, which is 4. Okay. So therefore, our remainder, so therefore, the remainder, when that particular polynomial is divided by x squared minus 2x minus 3, it's going to be equal to ax plus b. So a, so it's going to be minus 2x plus 4. All right, okay, so these are questions in a way, in some degree, a bit theoretical. Okay, so yeah, so it requires a lot of thinking, and you need to put a lot of things together. But that is the thing. Okay, so you need to exercise and do a lot of questions like this until you get familiar, you know, and know how to deal with them. All right. So if you haven't done any question like this before, it's going to be quite difficult. But if you have done some question like this, and you have fully understood, then you can do a similar question like this one. Okay, so the main thing is that keeping in mind that, you know, when you have, from the moment that you have two variables or two things like this, a and b, unknown, you know that you're going to have to solve two equations simultaneously to find the answer for a and b. It's not other way, unless one of them are given. All right, so that was the answer of question 19. Now, the next section is about, you know, the coefficient of a polynomial and their relation with the roots. Okay, so I'm gonna move this section a little bit up there so you can see better. Okay, so we are going to come back, you know, to the other question later, when and after doing differentiation, but now we're going to do the sum and product of the roots. Okay, so this is something that we did in class one day, all right, and in here we're going to have to use it. All right. So question 23, they say if alpha, beta, and gamma are the roots of the equation 2x cubed minus 4x squared plus 6x minus 1 equals 0, find the values of, well, all that, all right? Okay, so question 23. Question 23. The equation is 2x cubed minus 4x squared plus 6x minus 1 equals 0. All right, and we need to find all those relations. Okay. Okay, so we need to find alpha plus beta plus gamma. Okay, and we know I'm gonna use this notation to indicate the sum of all roots taking one at a time, and that is going to be equal to minus b on a. Okay, so we know that that is equal to minus b on a. Okay, so what I'm saying here is the sum of the roots, so it's going to be alpha plus beta plus gamma. I'm going to use in this notation, so it's a shorter notation, just to save time and writing. Okay, so that is telling you, so therefore alpha plus beta plus gamma is going to be equal to minus b on a, which is negative 4 on 2, so it's going to be 4 over 2, okay, which is 2. Okay, so that is the answer for the first part. The second part, we have to find the multiplication of the roots. Okay, and for that one, we have a formula. So alpha plus beta plus gamma is equal to negative c on a. Okay, so you gotta remember this is going to be negative, positive, negative, so it's going to be 1 on 2. Okay, so I'm going to write the formula first, just to make sure that you remember. So for this one, it's going to be minus d on a. Okay, so therefore we're going to say alpha beta gamma is going to be equal to minus d, where d is negative 1, so it's going to be 1 on a, which is 2, so it's going to be 1 on 2, what we said before. Okay, and then 3. We know that when you take them 3 at a time, 2 at a time, so you're going to use this symbol just to indicate that we are taking then 3 at a time, or 2 at a time. We know that when you take them 2 at a time and add them, then the answer is going to be AB, so it's going to be C over A. Okay, so it's going to be positive C on A. So therefore, what they want, alpha beta plus alpha gamma plus beta gamma, that is going to be equal to 6 over 2, which is 3. All right. So to do the this well-known formula is very easy, because we actually have a formula for these 3. So we have the formula for this one, we have a formula for when you multiply them all together, and we have a formula for this, so we don't have any problem. Okay, but the problem is when you have to find things like part 4. In part 4, we have to find the answer for alpha square plus beta square plus gamma square. Okay, and we don't have any relationship, direct relationship between this and the coefficient. However, we can somehow create an expression that will involve 1 or 2 or all of them, and then we can use the answers. Okay, what I mean is this. So if you're going to find the answer for this, we need to get some expression which will give us, alpha square, beta square, and gamma square. And the logical thing to do, I suppose, is to do alpha plus beta plus gamma square. Okay, and then when you expand this, if you expand it, then well, that is going to be, let's do it step by step. So that is the same as multiplying it by itself, and then we're going to expand it and see what happens. Okay, I'm doing this because I know that when I'm doing this, somehow I'm going to have alpha squared, beta squared, and gamma squared. That is why I choose that expression in particular, right? Okay, now we're going to multiply. So if I multiply this by this, by this, and this, then we're going to have alpha squared plus alpha beta, and then plus alpha gamma. Okay, and then I'm going to move to the beta. So we're going to have beta alpha or alpha beta, and then we're going to have beta square, and then I'm going to have beta gamma, and finally I'm going to do it in here. So we're going to have alpha gamma, and then we're going to have alpha beta or beta gamma, and then we're going to have gamma square. All right, now if you look carefully, in here we have alpha square, beta square, and gamma square, so you're going to put them together, square plus beta square plus gamma square, and then I'm going to have 2 alpha beta, or you're going to have 2 alpha gamma, and then I'm going to have 2 beta gamma, so it's going to have twice alpha beta plus beta gamma plus alpha gamma, okay, and then plus beta gamma. All right, why did we do that? Is because now what I'm going to do, I'm going to make this the subject and move all the other stuff to the other side. So then I'm going to say, therefore, alpha square plus beta square plus gamma square is equal to this, alpha plus beta plus gamma square minus twice this. Okay, but the beauty of this is that I know what the answer for this is, and I know the answer for this is. Okay, so the answer for the sum is equal to 2, and then 2 squared is equal to 4, and then minus 2 times. Also, I know the answer for this one, okay, for the sum when taking 2 at a time, and it's equal to 3. So we have that. And then it's done. Okay, so it's going to be 4 minus 6. Okay, so the answer is minus 2. All right. Okay, so that's how you do the question. And then for the other one, we're going to have to do something similar. Okay, something similar to this one. So we're going to have to expand the bracket and then group them until we are able to use, one of all these formulas. All right. Okay, so I'm going to make space to do part 5, so I'm going to wrap this off. Okay, so this is question 5 now. Okay, so we need to find the answer for alpha plus 1, beta plus 1, and gamma plus 1. Okay, so we need to find the answer for that. Okay, if you expand this, we're going to have to, okay, let's expand this bracket first, so that may help you. So that is going to be alpha beta, and then alpha times 1 is going to be alpha, and then we're going to have beta, and then plus 1. And then we multiply that by gamma plus 1. All right, and then we're going to multiply this by this and this by this and this, and so on. So the first one will give alpha, beta, gamma, something that we know. And then alpha beta times 1 is alpha beta. And then we're going to have alpha gamma. and then plus alpha, and then we're going to have beta gamma, and then beta, and then we're going to have gamma, and then 1 times 1 is 1. Okay, so if you explain all this, then you have this. Okay, but now I want to look at this. So in here we have the multiplication. In here we have alpha, beta, gamma, beta, gamma. And then we have, let me see, we have this. We have alpha, beta, and gamma is there. So, okay, so you're going to group them. So we have alpha, beta, gamma. And then I have alpha, beta, and gamma. So alpha plus beta plus gamma, something that we know. And then I have the sum when taken 2 at a time. So I have alpha, beta plus alpha, gamma, and then beta, gamma from here. Okay, so I have these 3 groups. But then we got everything because this is equal to 2. Now this is equal to, the multiplication is equal to a half. Okay, the multiplication is equal to a half. And the sum is equal to 2, so plus 2. And when you take them 2 at a time, it's equal to 3, so it's plus 3. So I mean that the answer is 5.5. Okay, so that is the answer for those questions. All right. Now, when you do the alpha, beta, gamma business, it is very common to ask you to do the one that we already know. Okay, and then we're going to ask you to, in addition to this one, we're going to ask you to do something else that is highly related to this one. Okay, so you know that if we ask you for something else, then that is going to be very much related to one of these or all of them in some way. Okay, but that's how we do this question. Okay, that was the answer for question 23. Okay, so now we're going to do question 24. Okay, in question 24 we have a cubic. Okay, is x cubed plus ax squared plus b equals 0. And they say that they have 3 distinct roots. Okay, so 3 different roots, such that one is the sum of the other 2. All right. Okay, so if you say, let alpha, comma, beta, comma, alpha plus beta be the roots. Okay, that's what they're saying. So they are all different. Okay, but the only thing that we know is that the third one, the one that should be gamma, is equal to the sum of the alpha and beta. Okay, so we've got alpha, beta, and alpha plus beta. That's what they say. Okay, and then with all that information, then we have to show that a cubed minus 8b is equal to 0. Okay, so that is something that we need to show. Okay, solution. All right. Okay, so I'm gonna leave my notes in here. All right. So we know that when we add them together, so we know that alpha plus beta plus alpha plus beta in this case, when you add them together, the answer is negative a on that number. Okay, so in the formula it's like negative b on a, but in here we have a, so it's going to be negative a over 1. So it's going to be negative a. Okay, so that is what we know. Okay, but then this we can simplify, and in here we're going to have 2 alpha plus 2 beta. So that means that we're going to have 2 alpha plus beta is equal to negative a. So therefore, from here we have that alpha plus beta is equal to negative a over 2. All right, so that is what we have for the sum of them when you take them one at a time. Okay. Also, we know that when you take them 2 at a time. Okay, so when you take them 2 at a time, so this is when you take them 1 at a time. When you take them 2 at a time, then we're going to have, we do alpha beta, so we do alpha beta, and then alpha that, so it's going to be alpha multiplied by alpha plus beta, and then we do this time that, plus beta, and then alpha plus beta, and we know that that is equal to c on a. But can you see that in here the x term is missing? So that means that the value of c is equal to 0. Okay, so we're gonna say also we're gonna say note x cubed plus ax squared plus b is the same as x cubed plus ax squared plus 0x plus b. Okay, now we can see that in here we got a, b, c, and c is equal to 0. So I mean that this is going to be equal to 0. Okay, so it's going to be 0 over 1, which is 0. Okay, and then this is the note. To justify, this answer. And then you can see that we can put this as alpha beta, and then alpha plus beta is a common factor for alpha and beta. So I mean that we're going to have alpha plus beta multiplied by alpha plus beta equals 0, or we can say that we have alpha beta plus alpha plus beta square equals 0. Okay, so we have that. All right, and the third one is when you multiply them together. So it's alpha, beta, and the gamma thing, which in this case is alpha, beta, and then multiply by alpha plus beta. And we know that that is equal to, from this equation, okay, so it's going to be, so this is minus positive minus, so it's going to be minus b on 1, so it's going to be minus b. Okay, so we got that. All right, now we're going to see how we can use these three things together. So that one, so we got that one, we got this one, because how we use this one, and this one together. All right, so we need to see how we're gonna use them to find the answer. Okay, let's see how we're gonna find the solution for this. Okay, keep in mind that we need to prove AQ minus 8 multiplied by B is equal to 0. Okay, that is our goal All right. I know that what alpha plus beta is from here, and I really want to know what alpha beta multiplied by beta is, and we can do it from here. So I'm going to call this equation 1, this is 2, and we're going to call this 3. Okay, so we're going to say from 2, we have that alpha beta is going to be equal to negative alpha plus beta square. Okay, so therefore alpha beta is going to be equal to minus, and then alpha plus beta is equal to negative a on 2. So it's going to be negative a on 2 squared. So we're going to say that from 1. So therefore, we're going to have the alpha beta. Okay, alpha beta is equal to negative, and this will give you a squared over 4. Okay, that is great, and I tell you why. Because we already know that alpha beta is equal to this, and we already know that alpha plus beta is equal to this. So we're going to substitute this result and that result in here. Okay, so then we're going to say, now, alpha beta multiplied by alpha plus beta is equal to negative b, and then we're going to substitute. So we're going to say, we have that negative a squared over 4 multiplied by negative a on 2, that is equal to negative b. All right. Let's see. I really want to make sure that we have done all this correctly. Okay, let's see. So in here we're going to have positive. So we'll have AQ. So if you multiply right across over 8 is equal to negative b. And then we're going to have AQ is equal to negative AB. So therefore we have AQ plus AB equals 0. But in here we have plus and we should have minus. Okay, let's see where that is coming from. Okay, let's start from the beginning. So when you do this, so yeah, the formula says that when you add them together, so when you do alpha plus beta plus gamma, the answer is going to be minus whatever you have in here on a. So in this case, it's going to be minus a on 1, which is minus a. Okay, and then if you simplify this, then you're going to have 2 alpha plus beta is equal to minus a. So therefore, alpha plus beta is negative a over 2. Okay, so I think that we have that one right. Okay, the other one is this one. So when you do then 2 at a time, okay, so when you do alpha beta plus alpha, this is the gamma, which is alpha plus beta in this case, and then beta plus gamma, that is equal to the other coefficient, which is 0, because you can see that the x term is missing. So that is equal to 0. So that is correct. And then we have this, and then we have alpha beta. This is the same as that. Okay. And then we do the multiplication. So when you do alpha beta gamma, that is equal to minus b on a, which is 1. So it's going to be simply minus B. Okay, and let me see if I copied the equation correctly. Yes. All right, and let me check, because I got something a little bit different in there. All right. I think that there is something wrong in there, because this is definitely minus a on 1, which is minus a. So I mean that the correct solution should be a cubed plus 8b equals 0, not a cubed minus ab equals 0. I think that they did something wrong in there. Yeah. Okay, so I think that in here, from what I see, this should be plus, not take away. For all what I did, it should be that. Yeah, I think that they made a mistake in there. It's a typo, or I don't know what happened, but yeah. All right. So yeah, sometimes typos are confusing, because I confuse you when you're doing the question. But then if we done everything correctly, then yeah, we should say that they made a mistake in there. Okay, so the answer should be, it should be a cubed plus ab equals 0, not a cubed minus ab equals 0. Okay, but anyway, okay, so they make a typo there, and that's it. Okay, now we're gonna move on to question 25. All right, so you're gonna move this up again. Right, so now we're doing question 25. Okay, I hope the question is not that long, okay, but this is our polynomial, question 25. So P of x is equal to 4x cubed plus bx squared plus 9x plus 2 equal 0. Okay, so that is, we're not going to put 0 because we know that that is a polynomial equation. Okay, so they say the root of the polynomial equation, this one, are alike. Two roots of the equation are alike, and the other one is twice their sum. All right, let's see how we're going to interpret what they are saying. Okay, so we're going to say let alpha and alpha, the first two, and then they say that the other one is twice the sum of them. So it's going to be twice the sum of them, alpha plus alpha. Okay? Be the roots. That's what they are saying. Okay, so two of the first root are alike, and the other one is twice as the sum of them. All right. Okay, so here we have x cubed, x squared, x and 2. So that is great, because then we don't need to put any extra zero there, and we don't get confused. Okay, this is the same as saying or alpha, alpha, and then we're going to have 2, so it's going to be 4 alpha. Okay, it's the same thing. The roots. Okay, so that we have the roots, and then we're gonna start using, the relationship that we have for coefficient and roots. Okay, so the first one, okay, when you add them one at a time, then you have alpha plus 4 alpha is equal to minus b on 4. So it's going to be minus b on 4. Okay, so that's the same as saying 6 alpha is equal to minus b on 4. Okay, or alpha is equal to minus b over 24. All right, so that is something that we're going to be using probably. Okay, so this is, I'm going to call that one. And then when you take them 2 at a time, so when you take them 2 at a time, we know that we're going to have alpha multiplied, so it's alpha times alpha, so it's going to be alpha square plus alpha times 4, so it's going to be 4 alpha square. And then we're going to have alpha plus 4 alpha, so we're going to have another 4 alpha square. And that, okay, that is equal to 9 over 4. So that is equal to 9 over 4. But this means how many alpha squares? So we go 9. 9 alpha square is equal to 9 over 4. All right. So therefore you can say that alpha square is equal to a quarter. Okay, so alpha is equal to plus or minus a half. All right. Okay, and the question say that we're going to show that the value of b is equal to 12. Okay, how are we going to show that? We're going to substitute. Okay, we're going to substitute this value of alpha in here. Okay, so, and this is, we're going to say this is, yeah, this is 2. Okay, and we're going to say from 1 we have that alpha is equal to minus b on 24. All right, and then we substitute. Okay, so therefore we're going to have that b is going to be equal to minus 24 alpha. All right, so therefore we're going to have that b is equal to minus 24 multiplied by negative half, because that is one of the answer, and that will give us 12. Okay, that's what they say. Okay, but in here, can you see that in here we have that alpha can be positive or negative? So that means that in here we can have b is equal to positive 12 or negative 12. So how can we show that the b is equal to positive 12? Okay, to do so, I think that we have to do the third part. Okay, so the alpha, beta, and gamma stuff. Okay, in this case, we have alpha multiplied by alpha and then multiplied by 4 alpha. Okay, that is going to be equal to the last one. So this is negative, positive, negative, so it's going to be negative 2. Negative 2 over 4. All right, negative 2 over 4. And in here we have then 4 alpha cubed is equal to negative 2 over 4. And then from here we have alpha cubed is going to be equal to negative 2 over 16. Alpha cubed is equal to negative 1 over 8. So therefore the alpha is equal to 1 on 2. Okay, so I mean the alpha is 1 over 2. Okay, from here, because yeah, now we have to satisfy everything, and in here they say that alpha is equal to half and half only. Okay, and then if alpha is equal to half and half only, then when you substitute in here, then we have the problem. We have a problem again. Okay, so I'm gonna check my notes and then come back.